Let me show you a situation every programmer hits, but almost nobody explains. You start with a small program. It's clean. It's readable. You understand every line. Then the program grows. A new feature here, a quick fix there. And one day, you change something that should be harmless, and three completely unrelated things break. No error message explains it. No test tells you why. And the scariest part? You didn't break someone else's code. You broke your own. This isn't about experience. It's not about talent. It's about how software behaves as it grows. And this exact pain is why object-oriented programming exists. Early programs are deceptively friendly. You have some data. You write functions that work on that data. Everything makes sense because everything fits in your head. This is like a small restaurant with one cook. You know every ingredient, you know every recipe, but then customers show up. More dishes, more rules, more special cases. Suddenly, keeping everything in your head stops working. Here's where things start to hurt. Shared state. Multiple functions read the same data. Multiple functions modify it. None of them truly own it. Every function can touch the same data. No one owns it. So when something breaks, debugging turns into archaeology. You're not asking, is my logic wrong? You're asking, who touched this and when? And at some point, shipping features get slower. Not because they're hard, but because every change feels risky. Most people think complexity grows one feature at a time. But real systems don't work like that. Every new feature interacts with existing ones. Every interaction creates new edge cases. So complexity doesn't grow like a straight line. It grows like a web. Eventually, the hardest part of programming isn't writing new logic. It's understanding what already exists. Procedural programming asks a very specific question. What happens next? That's perfect for scripts. Perfect for small tools. Procedural programming isn't bad. It just stops scaling cognitively as systems grow. But large systems don't fail because steps are unclear. They fail because responsibilities are unclear. Who owns this data? Who is allowed to change it? Who enforces the rules? Object-oriented programming didn't appear because programmers wanted fancy abstractions. It appeared because engineers were drowning in complexity. Object-oriented programming asks a different question. What if data and behavior lived together? What if each concept owned its own rules? That's it. That's the core idea. Classes, methods, inheritance, those came later. An object isn't just a data container, it's an owner. It owns its state. It owns the logic that protects that state. The outside world doesn't change data directly. It asks the object to do it. Just like in a real kitchen. You don't walk in and grab random ingredients. You place an order. That boundary changes everything. As systems grow, teams grow. And humans don't think in global variables. We think in roles, responsibilities, boundaries. In a well-structured, object-oriented programming system, change becomes local. You modify one object. You understand the blast radius. You're no longer afraid of unrelated breakage. That confidence, not elegance, not patterns, is the real benefit of object-oriented programming. Now, let's be honest. Object-oriented programming can absolutely be abused. Too many abstractions. Inheritance where composition would be simpler. Beautiful class hierarchies that hide real behavior. These failures happen when people forget why object oriented programming exists. It's not about modeling reality perfectly, it's about reducing pain. If you remember one thing from this video, let it be this: stop asking, how do I implement this? Start asking, who should be responsible for this? That single question leads to better boundaries, even if you never touch inheritance. Object oriented programming exists because procedural code breaks under growth. It's a response to complexity, not a programming religion. And if you've ever been afraid to change your own code, that wasn't a personal failure, it was a design failure. Object oriented programming exists because thousands of engineers hit that wall before you and decided there had to be a better way. And this is just the beginning. In the next videos, we're going to break object-oriented programming down piece by piece. We'll talk about why classes are not object and why that confusion breaks everything. We'll see how encapsulation protects you from yourself, how abstraction lets you build systems without understanding every detail, why inheritance is powerful and dangerous, and why polymorphism is where object-oriented programming really starts to shine. So if this video made things click even a little, the next one is where most people finally stop being confused.